Welcome to the Boardroom Battle, Lafarge Edition. Meet Paulo Perez, Quality Control Supervisor for Metro. He's here with an idea that will save Lafarge thousands of dollars. The second person into the boardroom battle is Don Borton, Operations Manager for Metro. He's working closely with the cement plant to rid us and everybody of all their slurry water. And the last person into the boardroom battle is Rav Sandhu, Plant Superintendent. He's here to take what he learned at Kent and apply it all over the GVA. What do all these people have in common? They're going the extra mile for Lafarge, and in the process, battling it out in the boardroom. Paulo Perez has an idea that it will rid his yard of all the concrete coming back from job sites. With all the blocks littering our yard at Kent, and the cost of labor that goes into making them, there's a lack of sales, and it's taking up costly real estate. Don Borton has an idea of getting rid of all of our slurry water and selling it to the cement plant. Working closely with the employees at the cement plant, he thinks that they'll be able to use our water in their process. And finally, Rav Sandhu, who has an idea that'll take our underutilized EnviroPorts to the next level. After a lot of trial and error at Kent Avenue, a method has been developed to rid its yard, and possibly others, of all concrete slop coming from the ponds. Using the same procedures with a few modifications can take this idea to Cass Brothers to rid its current problem of $64,000 a year in disposal fees. It all comes down to this: the Board of Executives. It's their decision to see where Lafarge's investment dollars must go.
In 2011, the Metro Ready Mix Division spent approximately $215,000 on waste disposal. As part of our goal of zero discharge, zero waste, we've been working with the Cement Division on a few items. Excess high pH water generated in our production must be either treated and discharged of, or trucked off-site and disposed of. In both cases, there are costs involved and potential environmental impact. We have sent a sample of our high pH water to the Cement Division for testing. They have indicated there may be a market for the sale of high alkaline water. This could generate some revenue and lower our costs involved with discharge or disposal. We have also sent a sample of our EnviroPort sludge to the cement lab. They are researching to see if they could dispose of the ready-mix byproduct in their cement production process and in effect lower our disposal costs. And finally, we have sent a sample of LKD, lime kiln dust, to the cement lab. LKD is a byproduct of dolomite lime production and usually is a waste product that goes to a landfill. Lafarge Ready Mix has developed a use for it as a filler in some of our mixes, such as Agilia. Our LKD is purchased through Greymont from the Pavilion Lake plant outside Kamloops. Although the material is inexpensive, the trucking cost is high. Our landed cost is about $70 per ton. Lafarge Cement has a byproduct from their production called CKD, cement kiln dust. This product is usually used in soil stabilization and landfills and help to dry up wet areas. The lab is testing to see if CKD could take the place of the LKD as a filler in our mixes. If it can, then the next step would be to see if it would be more cost-efficient alternative to LKD. Presently, the CKD is produced at the Lafarge Exshaw cement plant, but not at the Richmond site. The cement division rails the product to Seattle, where it is used in the above situations. If the cost to haul from Seattle is less than from Kamloops, we can then acquire internally at a cost savings. Richmond may also be able to generate CKD if it was shown to be cost effective. This would result in greater savings to the ready mix division.
One of the most common problems we have in our industry right now is trying to achieve a balance between economic pressures and sustainable practices. Like any other industry, like metal or timber, we want to get as much market shares by being competitive in our raw products, but at the same time we need to have a sustainable practice for future generations. So one of the solutions that we propose is the use of recycled aggregate in new concrete. For this purpose, we are focusing more on the leftover concrete as opposed to demolished waste concrete, as leftover concrete has less chance for contamination such as chlorides, sulfates, and oils. It's easier to crush because there's no rebar, etc. By doing this, we also need to set up a mobile crushing operation that can move from one plant to another and dedicate a stockpile area to control any leaching. So how are we going to make this happen? One of the barriers that we have right now in this market is consumer uncertainty with regards to the quality and consistency of this product. Basically, there's lack of practical engineering data, this recycled material. Also, there's no developed performance requirements to meet industry standards. So how are we gonna get over this hurdle? We need to get the engineering and the industry community engaged here. Basically, we need to get third-party testing performed in this type of aggregates to determine potential reactions with the new concrete, quantify performance requirements to meet CSA guidelines, and develop best practice guides for the GVA market. By doing this, we're able to determine how much recycled aggregates are we allowed to use per exposure class, per structure, per project. By doing that, we're changing the market. We're allowing the market to use this material at a known quantifiable amount. Okay, our group has performed a cost-benefit analysis to find out if this will make financial sense to our business. In our model, we have used average daily return concrete of 69 metric tons, and target amount prior to crushing is around 2,000 metric tons of materials, and our crushing frequency should be around twice a month. After running all the numbers, we found out that it's going to cost us about 70 cents per cubic meter per year to run a crushing operation. But the benefit there would be around $2.50 per meter per year. This is determined by using last year's numbers and percent replacement of around 10%. Our net unit savings around $1.80 per cubic meter per year. That gives us a total yearly savings of $880,000. The 10% recycled aggregate number that we used are pretty conservative compared to a more established market. They've been using around 20 to 30%. But in this market, I think it'll be safe to start at 10%. But after running all the tests, determining all the required parameters, we should be able to increase that and maximize our savings.